Hello friends, we are continuing the correction or the error in the tapes and how we can calculate the actual length from the measured length with the combination of all the errors. Here the slide shows a formula. The actual length can be calculated, that is L suffix A is equal to L suffix M, that is the measured length, with the chain or tape which has some error. What are the error we have discussed is due to temperature the length may varies, right? Due to the chain may be short or long, right? Due to the catenary or the sag by holding both the ends of the chain in the air, or using the chain in the slope area and consider that as a horizontal, then how the correction has to be, and the applied pull or the tension over the chain or tape. So these are the errors we have seen. So for those errors the correction has to be applied. If the mean temperature and the field temperature are different, there will occur the error in temperature. If the chain length is short or long, the error will happen. The sag error is always negative and the slope also always negative, we have discussed, and due to the pull applied, that also either positive or negative. So we have discussed about the formula of those all the things. Let's discuss with the problem, right? Here I have shown a problem, but in this similar way no problem will be given in the exam. For our understanding purpose, I have splitted the problem in different stages such that you can understand the given data, how it was given and how we have to take for our calculation, right? This problem will be given as a simple paragraph in the exam, right? So you have to, from that paragraph you have to take the given data, right? A steel tape of nominal length 30 meter was used to measure line AB by suspending it between supports, right? The following measurements were recorded. From the first two line itself, it was the maximum length measured is 30 meter only, but the problems may differ, it may goes to thousands of meter. So but this is the example, you can match this with any number of things, right? So here the line is AB, so it was mentioned as AB. The length measured, it will be in the given data, is 29.872 meter with the help of 30 meter chain, and it was given that the slope angle is given, that means the tape used in the slopy terrain. This given data may they give the measurement was made in a slopy terrain, like that they may hint. So what was the slope of the terrain? If 30 degree, 40 minutes, or whatever the degree if they mention, you have to match with the theta, right? Slope angle. And the temperature availed in that field is 5 degrees centigrade. Here also degree, here also degree minutes, so don't get confused. If the unit was given to centigrade or Fahrenheit, whatever it is, then it related to the temperature. All the other thing, the degree and minutes or seconds, it belongs to the angle, right? Then the tension or pull they may give, right, in the applied field. Here in the problem it is 120 Newton. But what was the standard length, what was the standard pull, what was the standard temperature while manufacturing the tape or chain? The standardization length of the tape against a reference tape was known to be the used tape itself 30.014 meter at 20 degrees centigrade. This is the temperature they used in the manufacture of chain, and the pull they have applied is 50 Newton. At that time the length was 30.014. So that was the standard length, but we consider it as a 30 meter, and with that we measure 29.872, right? Additional data is, if the tape weighs 0.17 Newton per meter and has a cross sectional area of 2 mm square, calculate the horizontal length. That means what? By suspending in between supports, so there may formation of sag, right? So if the sag is there, it is due to the self weight of the tape or chain. Then the area has to be calculated. For that, the given data can be used. The tape weight per meter, it was given the small w, so the total length, if we product, gives a capital W, and the bottom area is 2 mm square. So these are the different datas. In this problem all the errors are there, right? In some problem minimum error will be there, either 2 errors or only 1 error. Based on our understanding, you have to apply which error to be corrected and the actual length to be calculated. For your understanding, this problem consists of all the errors, right? There is a change between the pull, right? There is a change in the temperature, sag is there, slope correction is there, the chain is short or long. 30 meter is long, I think so, 30.14, right? So all the errors are there. How we can calculate? The next slide shows all the calculation and how it was calculated is going to explain, right? So the temperature correction, we know the formula, that is a measured length into the alpha is the coefficient of temperature into the difference between the temperature. The difference between the temperature, already we have mentioned, the temperature in the field minus the standard temperature, right? T minus T naught, right? So here it is, the error is obviously negative, right? So 29.872 is the measured length into the coefficient of temperature for a steel tape. It was not given in the problem. If it is not given, you can assume this value for all the steel or tape, right? 0.000040112. This is the standard value for the coefficient of expansion for a steel tape, right? Steel tape or chain. So the answer, if you go put it in the calculator, you get minus 0.0050 meter. Mostly you try to have 4-digit values in the chain calculations, right? Next, based on the chain is short or long, we have to determine the error. The measured length is again 29.872. The chain standardization is 30.014, but was the nominal length is 30 meter, it should be. So the difference between divided by 30 gives, it is the positive error. It may be vice versa. If the chain is short, it is vice versa, then it will be negative, right? So now we have the answer for that. Next, we will come back to the sag lastly. Here the slope angle is given, so we can directly use, since the slope correction is negative, you include the minus, so measured length into 1 minus cos theta. If the angle is not given, the level difference must be given, so h square by 2l can be applied, but here it was given directly. So 29.872 into 1 minus cos 3 degree 40 minutes. So which is answer is minus 0.0611. You also use the calculator, check whether the answer is coming or not. right? And the tension correction, you know the formula, it is T minus Ts, or the P minus P naught Lm, this is a measured length, divided by Ea. E is the Young's modulus and area of the chain or tape, right? So the pull applied during the measurement is 120, the standardization pull is 50. So here the difference is positive, so the correction also positive, and it may be vice versa also, right? Into the measured length divided by Young's modulus. For the steel table, already I have said 2 into 10 power 5, here they have mentioned 200 into 10 power 3, both are same, into the area given is 2 mm square in the problem, so it was substituted, you have obtained the tension correction. If it is different, it may be negative also. And the last one is sag correction, it is always negative. See, the sag and the slope is always negative, and the remaining 3 may differ, right, based on the difference, right? So you have to be keen in this, how to apply the correction. So you know the formula, it is W square Lm cube cos square theta divided by 24 T square, T or P square, tension or pull. Better you remember as pull, since the temperature also they are denoting with the T, it may be changed to P also, pull or tension, right? So here the small w is, in that it was given 0.17 Newton per meter, so it was just substituted per meter. What was the measured length? For that measured length, what was the weight? So 29.872 the whole cube, cos square, again the theta, which can be replica from the slope angle, the same slope will be followed, right? 3 degree 40 minutes divided by 24 into the pull applied in the field, right? So here we have used the T 120, not the 50. 50 is the standard, so here the applied pull has to be given. So if you made the calculation, the answer is minus 0.0022 meter, right? So now we have to determine the total horizontal length, the true length, actual or the true length, that is, which is equal to, this was the measured length, from the top we will combine, the temperature correction is negative, we have substituted here, and the plus 0.0139, which is the true length, standardization length of the chain. Based on that, it is positive, we have added. Next is the sag correction, always negative, minus 0.0023, minus, again the slope correction is also negative, we have applied the same, and here the tension correction become positive. Yeah. If you get combine all the things, you will get 29.823 is the measurement. So this much only, the difference 29.872 get converted to 29.823. It is just 0.05, right? For this much accuracy we have to calculate, sir. If it is continued for thousands of meter, what will happen? Listen friends, so it will get accumulate, so it has to be in actual terrain. If we use the chain for kilometers of distance measuring, while starting the chain may be standard, in between it may get expand, after a time it may get contract, right? So all at what distance it get expanded, at what distance it get contracted, all the things has to be checked with the standards. Then you have to apply between those distance alone, then you have to combine all the distance, right? So in that, which error to be considered, which not to be considered? If the chain is rolled on the ground, obviously the sag will be eliminated, right, since there is no holding. so that error can be avoided, right? If there is no temperature variation from starting to end and it is similar to the manufacturing temperature, then it will be 0. Or but if the standard temperature is maintained and the field temperature is slightly different, you have to apply. It may vary from morning to afternoon, afternoon to evening, or if you continue for the night, the temperature varies. Then you have to check whether it is a positive or negative, right? Then but at the initial stage the chain may be exact 30 meter or 20 meter, but by continuously using in a hot or cold environment, the length may vary, either long or short. It has to be checked with the standard distance. Then you have to, whether you have to apply this or not, you have to think. If it is slopey terrain, you have to get the theta value. If you are not able to get the theta value, then how we can calculate? Here the role of leveling will come. With that, from one point to another point, what is the elevational difference? With respect to that, you can calculate the h. So that h can be used h square by 2l, right? So based on the given condition, you have to check whether I need to apply all the correction or not. I hope you have understood the correction and how it has to be applied for a problem or in the field, right? Dear friends, I will post a assignment question after this video. You have to submit by the time given in that MS Team platform. You have to submit through that, right? I hope you will do it, right? All the best. Thank you.